Hi guys, in this video we will see the implementation of stack and queue using LinkedList. Previously we have seen how to implement stack and queue using arrays. In this video I'll teach you how to do implementation of stack and queue using LinkedList. First of all, we have learned what is a LinkedList. What is a LinkedList will contain? Generally a LinkedList will contain nodes. Each node will contain data and a pointer to the next. Okay, so let's see how to implement stack and queue using LinkedList. Here I have created a class called node, and using init constructor I have passed argument self and data. Self.data is equal to data and self.next is equal to none I have initialized. And then to do stack and queue in both the same code, I have created two classes. First one for stack ds, and second one for qds. So using these two classes I'll perform stack and queue operations in the same code. Okay, now we will see how to do for stack. Generally what stack will contain, we know stack will contain top reference. Why means we'll do insertion and deletion only at one end, because stack is of LIFO order, last in first out order. So using top only we'll do insertions and deletions. So here I have initialized self.top is equal to none, and I am giving up a function here called push to push data into the stack. So self.push, and I am creating a new node for that this class. New node is equal to node data, and if new node equal to none means the stack or the linked list is full, so we'll print overflow. Or else new node dot next is equal to self dot top. Why I am giving this condition here is, generally if I have for example 10, 20 and 30, 10 is my first element and second I have inserted 20 and then 30. So 10's next will be having null, and 30 will be having reference to 20, and 20 will be having reference to 10. So what I have to do, I have to create another new node called 40. Then 40's next must refer to 30. So self.top will be having the top element which is 30. So new nodes next, for example 40 is my new node, 40's next should be referring to 30. So self.top is equal to self.top I am giving. Now I have to make self.top as new node, because always my last inserted node must be new node. So self.top is equal to new node, and here I am giving another function called pop to remove an element from the stack. So if self.top is equal to none means there is no element present in the stack. So if there is no element I can't remove anything, so I am printing here underflow. Or else if some data is present, I am taking t is equal to, I am taking self.top into a variable called t, and t is equal to temp.data, means temp is equal to t.data, means self.top.data, means this data I have to delete. So what I will do here is self.top is equal to t.next. What self.top, if I remove self.top, if I remove, for example if I remove 30, 20 must be pointing to top, so self.30's next will be 20. So self.top is equal to t.next, and then I'll t, which is self.top, this t I'll remove. Now top will be, if I remove 30, top will be 20. So and I am returning here temp, which is t.data, means self.top.data, which element I am deleting, that I am returning here, that's all. And display, what is display? I have to display the elements in the stack. So what I have given condition here is, if self.top is equal to none means nothing is there, no element is present, so empty stack. Or else if some element is present, I have to traverse to the list from first element to the next last element. So t is equal to self.top, I am taking self.top into t while it is not none. Until it is not none, what I am doing is print t.data. Self. Means self.top.data, and then t is equal to t.next. This loop will run until there is none encountered in the next. So t.next for second loop it will be having t.next.data, next t.next.next.data, like that will print the whole stack. And then here we will see how to do queue implementation using linked list. We know queue will contain front and rear, two ends, and insertion is done at rear end and deletion is done at front end. So I have initialized front and rear to none, and enqueue function to add the data, and new node is equal to node of data. If self.front equal to none and self.rear equal to none means no element is present, then I have to make self.front is equal to new node and self.rear is equal to new node. Both are pointing to new node means then only one element is present. Or else if any two or more elements is present and I have to insert, where I have to insert, I will insert at rear end. Insertion is done at rear end in queue. So self.rear.next, so last elements next must be pointing to new node, and self.rear means last element should be rear, so self.rear is equal to new node. And to delete an element, if self.front equal to self.rear equal to none means there is no element present, so I will print q is empty. Or else If self.front equal to self.rear, what this means is only one element is present. Then I'm taking self.front in t. Why I'm using self.front is deletion is done at front end, so t is equal to self.front I am taking. If I remove, then there will be no element, so self.front is equal to self.rear is equal to none, and I am taking t dot data means self.front dot data. That data I have to delete. So what I'll do is I'll delete this front. And then I'll return temp is that data. In that self.front, what data is present, that it will return. Or else if some more elements are present, like 2-3 elements are present, then what I have to do? T is equal to self.front I will take. I'm taking self.front into some t variable, and t is equal to temp is equal to t dot data means self.front dot data, and I'm giving self.front is equal to t dot next, because that element will be removed and that next must be pointing to the front. So self.front is equal to t dot next, and then I am deleting t and I am returning the element which I am removing. And then here same display I am displaying the elements. If self.front is equal to rear is equal to none, then there is no element, so empty queue, or else I will traverse to the list self.front.data or self.front.front.data. Like this, I'll traverse to the t is equal to t dot next means t dot next dot data, t dot next dot data. Like this, I'll traverse to this and I'll print the data present in the queue. Now here I am giving another function called stack function. I have created object for my this stack ds class. I have created an object, and I am using while loop. I am displaying options for the user, and based on the user's choice, I'll invoke the respective functions. I'll return the result. And same way as I have done for stack, I have done for queue also the same thing. I have created an object using while loop. I am taking input from the user, and I am invoking the respective functions, and I am printing the result. That's all. So let me check whether it will run or not successfully. See, it I have given linked list, linked queue, exit. If my choice is 1, push, I'll push data. It will ask me to enter the data. I'll enter 10. If I will again given 1 means it will ask to enter the data. I'll push 10. If I give 5, it will again printing something, or else if I give 4, it will exit the loop. That's all. Thank you.